So we've talked about lean manufacturing, and now we're going to go to just in time. Sorry, we need to skip through these. Okay, so just in time. What is it? We've talked about that a lot. It's when a component arrives where it's needed, exactly when it's needed. And so what happens is it doesn't get there before, you don't have an excess inventory. It is the next workstation that determines what the production in the previous step is going to be. All right. It minimizes WIP, that's work in progress, and manufacturing lead time. BMW does this to a T. Literally, seats are arriving on the automotive assembly line right as it is needed. Other parts too, but that's one of the many parts. Okay, so must have and just in time. You have to have a production control that runs on a pull system. You got to have setup time reduction because you want to run smaller batch sizes. And you have to have stable and reliable product operations. Okay, a push system is when parts are produced at each station no matter what the immediate need is. It's the mindset, make all we can just in case. All right, so here I drew a sketch of a push system. This is in a typical manufacturing operation. So you start making part A and you just keep making part A. So say you can make 20 per hour at this station, part A, the first step in manufacturing process. Okay, so you make 20 per hour, but the next station can only use 10 of yours every hour. So you just keep making. Then part B, okay, you use part A to make part B. You keep your bins full. You make 10 per hour, because that's what you can make no matter how many the next station needs. All right, so C can only make 5 per hour, and they only need 5 of part B. Part B was 10 of them were made. So at the final step, you make 5 parts every hour, but the customer only wants 3. That's a push system. In the meantime, you have excess inventory accumulating here and here and here. Okay, so you have a lot of inventory accumulating. A pull system, the order to make and deliver parts at each workstation in the production sequence comes from the downstream station. Okay, so production control doesn't say make these many parts. All right, they say make these parts, and then you use that to backfill your factory kind of thing. All right, so when I drew this sketch for you, the customer wants 3 per hour. All right, part C though can make more than that. Okay, but they make their 3 per hour and they're shipped directly to the customer. This part B, they can make 5 per hour, but they only make 3 because that's what we need downstream. This station's only going to pull 3, so they only make 3. Part A, they could make 10 an hour, but they only make 3 because that's all that they're going to need, or the customer wants. Okay, and so this is a pull system. You start by thinking at the end and moving backwards. I literally drew this picture backwards. I started at the end. Okay, so this is the upstream station. This is a downstream station. This one is upstream from C, okay, but downstream from A. And so this is different than the push system. Okay. All right, Kanban system. It limits the amount of inventory that accumulates between operations. The control mechanism is you only make the parts needed by the next step. Remember, we talked about the different kinds of waste, and remember, if we look back to our push system, we have a lot of extra costs. We've wasted these people's time making the parts. Now we have to move the parts. Now we have to store the parts. We have extra equipment. We have extra facility space for storage. We have a wide variety of costs from all the extra inventory we've made in this process. Okay. In this process, we've saved a lot of resources. Remember, these operators are flexible. They're highly trained. They can do other things since they basically had a great deal of free time here. All right. Setup time reduction. So if we want to minimize the WIP, we have to minimize the batch sizes and the setup time. All right. And this is a calculation that lets you determine the batch size. It's the square root of 2 times the annual demand times the setup cost divided by the holding cost. And these equations are found in your textbook. You're welcome to look at them there. They're written in terms of variables, but it might be confusing because they do actually go through the derivation. Okay, so that batch size will minimize the setup and the carrying costs. All right, so why do we reduce the batch size? Reducing the batch size reduces the average inventory. Your average inventory level is half your batch size. So that's how we save money. Remember, if we reduce inventory, we reduce our money that's tied up. So to reduce the batch size, right? If we look here, batch size, we have to reduce the setup cost. Now to reduce the setup cost, we have to reduce the setup time. So we want to reduce the setup cost. And that's the one we have control of, really, the setup cost. So to do that, we need to reduce the setup time. All right, so setup cost is the cost per hour of the machine being down times the number of hours it's down. The holding cost per unit is the holding cost rate times the unit cost. So that's going to be a number like 18%, 20%, 12%. Okay. Ordering quantity is the setup cost times the annual demand divided by the optimum batch size. All right. So these are just a few definitions, and we're going to use them in calculations. All right. So the total cost of your inventory, total inventory cost, is the total holding cost plus the ordering quantity. Okay, so when I swap in the formulas on the previous page, that means that the holding cost times the batch size divided by 2 plus the setup cost times the annual demand divided by the optimum batch size, that's going to be my total inventory cost, and that's what I want to reduce. So again, to reduce these things, I need to reduce the setup cost, which means I need to reduce the setup time. That's why I want to reduce the setup time. All right, so here's an example. The setup time of a certain product is reduced from 5 hours to 5 minutes. Just so you'll know, that is not unreasonable. That has happened. All right, streamlining processes. The annual demand for the product is 1,500 pieces per year. The unit cost is $20. The holding rate cost is 18% per year. The cost of downtime during the setup is $150 per hour. What was the total inventory cost before and after? All right, so let's look at before. The setup cost is the cost per hour times the number of hours. So that's 150 times 5, that's equal to 750. The holding cost, okay, is the holding cost rate times the unit cost. So we do 18% times 20 equals $3.60. So to find our optimum batch size, we do 2 times the annual demand, that was 1,500 right here, times the setup cost, we found that to be 750, divided by the holding cost, 360. We take the square root of that and get 2,500 units. All right, the total inventory cost then right now is going to be the holding cost times the batch size divided by 2. So that is $3.60. We calculated that number. The batch size we just found, 2,500 divided by 2. Plus 750, the setup cost, times the annual demand was 1,500 divided by the optimum batch size. This is basically, okay, setup cost times how many times do we do that setup? Okay? How many times do we do that setup? So when I work this out, I get $9,000. Now we're going to change it to reduce the setup time to 5 minutes. So now it's 150 per hour times, this is 5 divided by 60, so 0.833 hours, and we get $12.50. The holding cost is the holding cost rate times the unit cost. That's the same, $3.60. So now we find the optimum batch size. 2 times annual demand. Now the setup cost is smaller, $12.50. Divided by the holding cost, $3.60. So now we've reduced the optimum batch size to be 323 units. Okay, that's a big reduction from 2,500 units, right? Remember that our average inventory is going to be half the optimum batch size. So we're at half of 2,500 or half of 323. Huge difference. All right, so the total inventory cost is going to be now 360 times 323 divided by 2. Okay, because remember we're finding the holding cost of the inventory, so this is our average inventory is going to be 323 divided by 2, and we have to hold that. And then this is how many times we have to do the setup now, so 1250, that's a much smaller number, the setup cost, divided by this ratio, annual demand divided by optimum batch size, right? And that's 1,161. All right, we went from 9,000 to about 1,000. If I do the percent cost reduction, I do what it was minus what it is now, divided by what it was before. That's 87%. Huge change. So this is the kind of calculation you're going to need to do on setup reduction.